Alright, so today we're going to talk about a molecule called 3-pentanone. A few little facts about 3-pentanone are posted here on the side. It is a liquid at standard temperatures and conditions. Its melting point range is from -42 to -39 degrees Celsius. Boiling point range from 101.7 to 102 degrees Celsius. The major and only functional group present in this molecule is going to be our ketone, and it's going to have 1 degree of unsaturation from that ketone, as we'll see when we draw the structure. When we look at our name here, we see that our parent chain is a pentane, which is a 5-carbon chain, so we'll go ahead and draw that out. So we'll start here with our terminal carbon at position 1, 2, 3, 4, and 5. And now we see from our molecular formula we've accounted for all 5 of our carbons. Now we'll go on filling in our hydrogens just to see kind of where everything forms. So we'll go with our 3 hydrogens on the end here for both carbons, because we do notice symmetry with our molecule already. We'll know that both of these can only hold 2 hydrogens because they're already bonded to another carbon. From our octet rules we should have learned in Gen Chem, each carbon can form 4 bonds, meaning it holds 8 electrons in its valence shell. So we'll do 2 more hydrogens here also. The way that I like to think about it is that our carbons here on the end are already only bonded to 1 carbon, so we have to go ahead and account for those 3 other spots with hydrogens. Hydrogens can only contain 1 of those bonds. So the question becomes, what do we do with our final remaining carbon here in the middle? And so if we look back at our name, we notice the NONE suffix indicating a ketone group. And what a ketone group is a carbonyl group. So a double bonded oxygen is going to be placed at our carbon 3 position, and we see that from the name that we have here. So we will go ahead and form our double bond here. And so this is the structure for 3-pentanone, and we will go ahead and build that after we notice that our degree of unsaturation comes from our pi bond that we formed here in our ketone group. So that way we can see that we have our 15 sigma bonds and 1 pi bond, where our 1 pi bond attributes to our degree of unsaturation. So we'll go ahead and build this structure with our Snatoms, just so we can have a visual representation. All right, so we'll go ahead and build 3-pentanone with our Snatoms kit. So we'll start with our carbon at position 1. We'll notice that each white ball representative of a hydrogen, the black of carbon. So we have a carbon. It is going to be bonded 4 times. 3 are taken up by hydrogen, which will give us 6 of its valence electrons filled. Then its 8th will be filled by this carbon at position 2, which is a methylene group, our CH2 right here. Then our carbon at position 3 has that carbonyl group bonded to form our ketone functional group right here, that C double bonded to O right there, which will be connected to another methylene And finally, a methyl group at the end. So notice we have symmetry around our carbon 3, or our ketone group. And that's 3-pentanone.